Here is an interesting twist on an alternating series. For what values of a can you have as that exponent so that the series will converge? So first of all, I could rewrite this as take this -1 to the n minus 1 part, move it to the side, and then times the 1 over n to the a. And so this part right here is what's making it alternate. And so when we do the two parts for the alternating series test, the AST, one part says you need to take the limit as n goes to infinity, and you don't have to pay attention to the plus minus part, but the limit of this needs to become a 0. So what could a be? If, for example, a was a 1, then we would just have this, the limit as n goes to infinity, 1 over n. Well, 1 divided by infinity is 0, so that works. So if a is a 1, it works. What about if a is a 2? Well, that just means 1 over infinity squared. That's still 1 over infinity equals 0. So the 2 works. And of course 3, 4, etc. What about if you put something like a fraction? So that would mean the square root, and 1 over the square root of infinity is still going to be 1 over infinity, which is still going to go to 0. So fractions work. All right, we did whole numbers, fractions. What about our special friend 0? It says no, you cannot do that, because n to the 0 is a 1, which means that you get 1 over 1, and that does not equal 0. So n equals 0 does not work. So n cannot equal 0. What else? What about, I haven't tried negatives. So what about if you use a negative? So if we then say the exponent is, say, a -1. Well, in that case, that means invert the fraction, so you get n to the 1. And if n is going to infinity, well, that does not equal 0. So that's not going to work. And in fact, any negative exponent that you do will invert it and make it become infinity instead of becoming 0. So that means that n cannot equal 0, and n cannot be negative. So that means n needs to be a positive number. So we're not necessarily going to narrow it down to, hey, a has to equal 1/13 or something like that. Oh, sorry, I wrote down n and I meant to write a. So the a has to be a positive number. Okay, the second part says that the a n plus 1 has to be smaller than the a term. So if I put an a plus 1, sorry, the letter a and the letter n are being used in two different ways. So if you substitute a plus 1 for the exponent, is that smaller than when you just have a? So is that always true or sometimes true? Let's see. So you can invert the fractions. This one will become n to the a plus 1. This one will become n to the a. And then that inverts the inequality. So for what values of a is it true that n raised to the a plus 1 will be bigger than n to the a? Well, since n is a positive number, in fact, n starts at 1. Since n is a positive number, you can divide both sides by n without changing the inequality. And in fact, I'm going to divide both sides by n to the a. On the right side, that's pretty easy. The na equals 1. So a na divided by a na equals a 1. And then on the left side, na will cancel the a on that one, so it just leaves n. So n has to be a number bigger than 1. Well, n is starting at 1, and it doesn't really matter what happens the first term. As long as n is bigger than 1, it works. So it turns out this one did not give us a restriction on a, only this one did. It says a has to be positive. So this is the final smiley face answer. As long as a is positive, it will converge.